This is an English listening video summarizing 10 perfume trivia facts. Enjoy a relaxing listening experience. Coffee beans at perfume shops. At perfume shops, you often see bowls of coffee beans. The traditional thinking is that they serve as an olfactory palate cleanser. After a customer tries several fragrances, they can experience olfactory fatigue, making it difficult to distinguish new smells. It was believed that inhaling the strong, simple aroma of coffee could clear the nose of lingering scent particles, effectively resetting a person's sense of smell. This was meant to help them accurately assess the next perfume. However, this long-held belief lacks scientific backing. Recent studies suggest that coffee beans don't actually clear the olfactory system, they just introduce another powerful scent. Scientists have found a more effective method is smelling something familiar, like the fabric of your own sleeve. Since your brain is so accustomed to your personal scent, it provides a neutral baseline for your sense of smell to return to. Consequently, the presence of coffee beans is now seen more as a traditional custom than a functional aid. Musk Anosmia. Musk is a foundational ingredient in many fragrances, valued for its rich quality. However, a significant portion of the population cannot smell certain types of musk. This condition is known as Musk Anosmia or specific anosmia. This is not a general failure of the olfactory system, nor is it considered an illness. It is a very specific inability to detect a particular chemical structure. Many people with this trait are completely unaware of it. They just perceive certain perfumes differently from others. The reason for this phenomenon lies in our genes. Our ability to smell depends on hundreds of types of olfactory receptors in our noses, with each type designed to recognize specific scent molecules. In individuals with musk anosmia, the gene that produces the specific receptor for musk molecules, for instance, one known as OR5AN1, is different or inactive. Because of this genetic variation, the receptor fails to bind with the musk molecules, and as a result, no scent signal is transmitted to the brain. Scent pyramid. Many people are familiar with the concept of a perfume's scent pyramid, where different aromas emerge over time. This begins with the top notes, like the citrusy scent of limonene, which are perceived immediately. As these fade, the middle notes, such as the floral scent of geraniol, become noticeable. Finally, the base notes, like the sweet aroma of vanillin, linger for hours. This temporal progression is not accidental. It is a carefully designed feature based on the principle of differential volatility. Perfumers select ingredients knowing that their molecules will evaporate from the skin at different rates, creating a dynamic and evolving fragrance experience for the wearer. The reason for this variation in evaporation speed lies in the molecule's physical properties. While molecular weight plays a role, a more significant factor is a molecule's affinity for the skin. Molecules like limonene have a relatively simple structure and are non-polar, meaning they don't bind strongly to the skin and thus evaporate quickly. In contrast, molecules like geraniol and vanillin possess polar functional groups, such as hydroxyl groups. These groups form weak electrostatic bonds with the skin's surface, acting like tiny anchors that slow down the evaporation process. The more of these polar groups a molecule has, the stronger its adherence to the skin and the longer its scent will persist. Perfume for astronauts. When astronauts return from space, they often describe a peculiar set of smells clinging to their suits and equipment. These descriptions range from burnt steak and hot metal to spent gunpowder. To better prepare astronauts for this unusual sensory environment, in 2008, NASA commissioned a chemist, Steve Pierce, to develop a fragrance that would replicate these reported scents. The primary goal was not for cosmetic use, but as a training tool. By exposing astronauts to the smell before their missions, NASA aimed to familiarize them with it, thereby reducing the potential for surprise or distraction during critical operations in space. Creating the fragrance, which later became known as Eau de Space, was a unique challenge. Since it was impossible to collect a direct air sample from the vacuum of space, Pierce had to rely entirely on the anecdotal accounts and memories of astronauts. He meticulously mapped their descriptions onto a database of known, safe aroma chemicals to construct a composite scent. Consequently, the final product is considered an educated approximation rather than a scientifically exact replica. Its main value lies in simulating the experience described by spacefarers, ensuring that the powerful and distinct odor of space does not become an unexpected element for new crew members to contend with. The oldest perfumes. When we think of the history of perfume, many people might picture ancient Egypt or Rome. But in Europe, the first alcohol-based perfume as we know it didn't appear until the 14th century. This was Hungary water, a fragrance distilled with brandy or wine, featuring rosemary as its main ingredient. It was initially promoted not simply as a perfume, but as a rejuvenating tonic. Legend says it was created for Queen Elizabeth of Hungary, who became so youthful after using it that she received a marriage proposal from the King of Poland. Because of such stories, it was widely regarded as a remedy for various ailments. While Hungary water is historically significant, the oldest perfume still in production today is the original Eau de Cologne, created in 1709 by Johann Maria Farina in Cologne, Germany. This was a revolutionary product. At a time when perfumes were typically heavy, with strong musk and floral notes, Farina's creation was remarkably light and fresh, dominated by citrus oils like lemon and bergamot. This clean, uplifting scent was a stark contrast to the fragrances of the era and quickly gained popularity among European nobility. The Farina family continues to produce this iconic cologne using the original secret formula. Digital fragrance. Digital fragrance refers to the technology used to record, transmit, and reproduce smells as data. While early attempts relied on electronic noses with physical sensors, recent advancements in artificial intelligence have revolutionized the field. A leading example is the work done by Google Research. Instead of trying to build a machine that can smell, their AI model analyzes a chemical's molecular structure and directly predicts what its odor will be. By training on a vast database of molecules and their associated scent descriptions, the AI can forecast the smell of new compounds without ever physically sampling them. The application of this digital scent data is also evolving. OVR technology, for instance, has developed a device called the Ei-Chan, which attaches to a virtual reality headset. This device contains a cartridge with various scents that can be released in coordination with events happening in the virtual world. For example, a user exploring a virtual forest might smell pine trees, or they might smell smoke during a simulated campfire scene. The primary goal of this technology is to deepen the sense of immersion, making virtual experiences feel more believable and emotionally resonant by engaging the user's sense of smell. Scent of rain. Many people are familiar with the distinct, earthy smell that follows a light rain after a dry spell. This phenomenon, known as petrichor, is often described as pleasant and nostalgic. For a long time, the precise origin of this scent was a mystery. Today, scientists understand that the primary component responsible for this unique aroma is a chemical compound called geosmin. This substance is not produced by the rain itself, but by specific types of bacteria that live in the soil. The mechanism by which this scent is released into the air is quite fascinating. When raindrops hit a porous surface, like dry soil, they trap tiny air bubbles. These bubbles then shoot upwards through the droplet and burst out into the air, releasing a fine spray of aerosol. This aerosol carries the geosmin, allowing the scent to be dispersed. The human nose is exceptionally sensitive to geosmin, capable of detecting it at concentrations as low as a few parts per trillion. How to make perfume. Many people have a romantic image of how perfume is made. They might picture someone harvesting lavender flowers and using a traditional distillation process. This classic method involves sending steam through a still filled with flowers. The steam carries the aromatic compounds, which are then cooled back into a liquid. From this liquid, the essential oil, being lighter than water, floats to the top and is carefully collected. This process has been used for centuries and is effective for extracting pure, natural essences. However, that image doesn't capture the reality of modern perfume manufacturing. Today, creating a fragrance is less like cooking and more like a high-tech laboratory procedure. A perfumer first designs a complex formula that can list over 150 ingredients, including both natural oils and synthetic molecules. Each component is then precisely weighed on an electronic scale. These ingredients are combined in large tanks and mixed with alcohol. The mixture is then left to age in a cool, dark place for several months to allow the scents to blend and mature. This reveals how modern perfumery is a fusion of artistry and advanced chemical science. Musk. When people think of musk, they might imagine a heavy, animalic scent. Historically, this was accurate. Original musk was a highly prized substance obtained from a gland of the male musk deer. Its rich, sensual aroma made it a luxurious base for perfumes for centuries. However, due to ethical concerns and the need to protect the musk deer, which became an endangered species, the trade of natural musk was banned under international agreements in the late 20th century. This shift has fundamentally altered the popular image of musk, moving it away from its animalic origins. Today, the musk we encounter in fragrances is almost exclusively synthetic. The most prevalent type is known as white musk, which offers a clean, soft, and skin-like scent, a stark contrast to its natural predecessor. This clean association was solidified as synthetic musks became widely used in laundry detergents and fabric softeners. An interesting challenge for perfumers is a phenomenon called Musk Anosmia, a genetic trait that makes some individuals unable to smell certain types of musk molecules. To address this, perfumers typically blend multiple synthetic musks with different molecular structures into their creations, ensuring the scent is detectable to a wider audience. The Chypre Genre. The word Chypre is French for Cyprus, an island in the Mediterranean. This fragrance genre traces its roots to a perfume released in 1917 by the brilliant perfumer François Coty called Chypre de Coty. Inspired by the aromas he experienced on the island, Coty created a revolutionary scent composition. It featured a distinct contrast between a fresh citrus top note, typically bergamot, and a deep, woody, mossy base built around oak moss and labdanum. This perfume was so influential that it established an entirely new fragrance family, and scents following this structural blueprint came to be known as Chypres. The classic Chypre structure has faced significant challenges in recent times. A key ingredient, oak moss, is now heavily restricted in perfumery due to regulations concerning potential skin allergens. This has forced modern perfumers to reformulate iconic Chypre fragrances and to innovate when creating new ones. This has led perfumers to seek creative solutions, such as using substitutes that mimic the scent of oak moss or emphasizing other elements like patchouli to provide a dark, earthy foundation. Consequently, many contemporary Chypres, often called modern Chypres, may have a different character from the originals, while still honoring the genre's core concept of aromatic contrast.